Today we're going to do compound inequalities. So we've talked about one-step inequalities and multi-step inequalities. Compound inequalities are just another type. They contain the words and or. So the first thing we're going to talk about are the ones that contain the word and. They have the word and. The compound inequality is true only if both inequalities are true. So then its graph is where the graphs of the two inequalities overlap, and that's called the intersection. So let's take a look at the graph. X is greater than or equal to 3, and the graph of x is less than 7. So let me get a number line on here. So I'm just going to consider the graph x is greater than or equal to 3 first. So if that was just my graph, I would need a closed circle, and greater than would be to the right. And if I was graphing x is less than 7, I would need an open circle since it's not having an equal to sign, and that would go everywhere to the left. Now my graph that I want, again, is that overlap or that intersection. So I can see the graphs overlap between these 2 points from 3 to 7. So my actual graph would be a closed circle on 3, open circle on 7, and that overlap that's shaded in the middle. It can also be written this way. So if you see it that way, that's an implied that it's an and. You can read that from the x is greater than or equal to 3, and x is less than 7. So if it's combined together, that's automatically going to be an and problem. So let's do one example. So we have negative 2 is less than or equal to x minus 3 is less than 4. Now there's 2 ways that you can solve this problem. Okay, you can split this up. The left part, okay, and this middle part is the part that repeats. Can be written, and then you can use the word and you can repeat and write the other inequality and then solve both of these for x. So to get x by itself in this left one, I would need to add 3 to both sides. To get 1 is less than or equal to x. I like having the variable first, so I'm going to flip that over. X is greater than or equal to 1. The second one, again, I'm adding 3. So to get x is less than 7. So x is greater than or equal to 1 and x is less than 7. So if I'm graphing that, 1, I'm just going to put the 1 and the 7. I'll make sure they are in order though if you're not going to put all of the numbers. So 1, we're going to have a closed circle. Okay, 7 is an open. Now greater than 1 is to the right, and less than 7 is to the left. Again, you want that overlap, so I'm not going to go past those 2 circles. Now, the other way you could have solved this problem, and you get the same answer, is you can just think of this as one giant problem. However, our 2 inequalities divide this up. So then we're trying to get x by itself in the center. So I need to get rid of that minus 3. So I'm going to add 3. Now I don't just have one other side to do that too. There's 3 parts to this, so I have to do that in each of these columns if I'm going to solve it this way. And I get 1 is less than or equal to x, which is less than 7. So graphing will be the same. I personally like to read that as x is between 1 and 7. But x is greater than 1, so to the right, and less than 7 to the left. So you get the same answer. So your choice if you'd like to split them or just draw the lines in. Make sure you do whatever you do to the center to all 3 columns. Now the second thing we're going to talk about are inequalities containing the word or. So ors are different. A compound containing or is true if at least one of the inequalities is true. So one of them could be true or both could be true. So the graph just includes the graph of both inequalities. You just graph the both inequalities. on the same number line, and that's called a union. So for example, if I have x is greater than 2 or x is less than or equal to negative 1. Now for or, you cannot have them combined together like you can with the and. It has to have the word or. So you'll always see the word or if it's an or. So let's draw a number line. Let's see, we got negative 1, 0, 1, and 2. First part says x is greater than 2. So that's an open circle. Let me change colors here. Open circle. And it's greater, so that will be to the right. And then x is less than or equal to negative 1. That's a closed circle. And that is going to be shaded to the left. So you just do both inequalities on the same number line. They do not need to overlap. They might, but you just graph both of them on the same number line for the union. So let's do one example of that. We have negative 2m plus 7 is less than or equal to 13, or, so see the word or, 5m plus 12 is greater than 37. So these are two different problems. Make sure you're not trying to solve them together. Okay. So I'm going to rewrite it. So we have negative 2m plus 7 is less than or equal to 13. I need to get the m by itself. So first I need to get rid of the positive 7 by subtracting 7 on both sides of my inequality. 13 minus 7 is 6. Next step, this is negative 2 times m, so the inverse operation is to divide by negative 2. Now this should ring a bell. When I'm dividing by negative 2, a rule should come in mind. Dividing by a negative, I need to change the inequality sign from a less than or equal to a greater than or equal to. Then we can solve this other one. 5m plus 12 is greater than 37. Subtract 12 on both sides. We would get 25. And last, divide by 5, and we have m is greater than 5. Now, again, we need to graph these on the same number line since it was an or problem. So what am I just going to do these numbers? Negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. Let's write them all. And let's see, we have greater than or equal to negative 3. Which is to the right, because it's greater than. And don't forget that closed circle. And greater than 5, well, that's already actually filled in, so that graph's already taken care of. I already have my 5 covered up by my other graph. So there's an example where they do overlap, so you actually only end up with one line because the lines overlap each other. So that's all there is to compound inequalities. Just be careful with an and or an or. And has to have some kind of overlap. If it doesn't, that would be no solution. And for an or, say you had one starting here going this way, and one starting here and going the other way, you ended up with the whole number line. So that would be all real numbers. So those are possibilities. You could get all real numbers, or you could get no solution if it's an and there's no overlap.